Special troubleshooting series called Divide and Conquer, Part 1. Good morning, YouTube, here on a Tuesday morning after Labor Day. Hope everybody had a great last weekend of the summer, officially. I doubt that the weather is going to change all that much, but you know, you never can tell. Here today, I'm going to start my little project that I've told you about. It's the Hallicrafters S38C, and we are going to try to power this up on the audio section only and provide tube filament voltage and B+ separately to the receiver and see if we can get just the audio section to work. I think this is a worthwhile experiment. There are times when you just don't have the proper power supply to power an entire radio. In other words, you can't put out enough B+ amperage and filament current at the same time to power the whole radio. Now this is, this is the way you can do it, I think, to have it both ways. In other words, I use the divide and conquer scenario on this. You can do this one stage at a time, and that's what we're going to try to do. Hopefully we'll get the audio stage active today and show you how we did it. And to that end, before I end up here sitting here talking to you all day long, I'm going to go ahead and jump into the explanation of how we're going to hook this up, where at on the radio it will be hooked, things like that. And in order to do that, I'm going to jump over here to the computer and we'll take a look and see on the schematic exactly what we're going to do. Stay tuned. Okay, what you see now before you on the screen is the schematic for the Hallicrafters S38C. And what we're going to do is show you the different sections first. And you can see there we've got the audio section up in the top right, the B+ or power supply in the bottom center, and over to the left of that is the filament string that we're going to be working with. What we're going to do is show you exactly which ones of the tubes we're going to remove. We're going to do that now. As you can see, the only tubes that will be left in the set will be the audio tubes, the rectifier, the IF tubes, all will be removed. And that's so we can just supply B+ and filament voltage to those two tubes and make sure that the radio is really not using any extra voltage or current, I should say, I guess, that it doesn't need to be using just for the audio section. So let's jump right into the explanation of what we're going to be trying to accomplish here. Okay, what we see now here is the audio section, and the audio input point is going to be the high side of the volume control as illustrated there. Now we're going to jump right into the path that we're going to take through these tubes and out the speaker, hopefully, and we'll try to demonstrate that here on the screen. First thing we're going to show you again is the high side is where we will input our signal. From there it will go through the volume control out the wiper. Now if you'll notice the volume control on one end is tied to ground. That is the low side. The high side is the active side or the input side. So our signal, according to how you have the volume control set, is the amount of signal that goes out through the wiper. So as you see, it goes out through the wiper and to a coupling cap, which is C24D there, and it will go through the coupling cap provided the cap is good. And this is troubleshooting 101, people. So this is how you do it. You signal trace. So like I said, after it goes through the coupling cap, it goes up to the grid of the audio preamp. Now, this tube here is the audio preamp and the detector tube. As you can see, there's two little places on the bottom there. Those are rectifiers, and they rectify the signal coming out of the IF into audio. That's what they do. But this tube also provides the first amplification of the signal. And again, you go through the grid there and goes to the plate. It is amplified there by a factor of whatever, and then goes out the plate over to the next coupling cap, which is C24A. Now C24A connects to the grid of the audio output tube. Now this audio output tube should, provided everything is working and that cap is good, give us the amount of volume or amplification we need to make the speaker work. So if you follow the path again, goes through the tube, amplified by the between the grid and the plate, out the plate over to the audio output transformer. Now the illustration there is you have it going through the primary of the audio output transformer. It is inductively coupled over to the secondary side, and from there it goes on down to the speaker. There's two terminals comes off the audio output, and they connect directly to the speaker. And at that point it should produce sound, and hopefully we're going to be using music for this. So okay, so next up what we want to look at is how we are going to power our radio, just the audio section. And what we see in front of us now is the filament section of the radio. You see the X's there. Those are the tubes that are removed. You see the rectifier on the right, the 35Z5 is removed. The V1 and V2 are the IF tubes. They are removed. And once you remove those, you have no more path for your filament to be continued. In other words, there's an open between V3 and V4 there. So what we got to do is put a jumper wire in there, as you see indicated on the green. And once we do that, then we can apply our 62 volts AC across a V3 pin 8, I think it is, and pin or B4 pin 2. It looks like, I can't tell exactly. The schematic's not that clear. But anyway, 62 volts is chosen because of the two tubes that we are powering. One is the 50 L6, and the other one is the 12 SK7, I think, or XQ7, but it was 12 volt filament. So combine the 12 volts with 50 volts, you get 62 volts. Now, when we do this actual powering up, we're gonna monitor this pretty close. Make sure we don't have excessive current. I believe, I've looked these up once, and I think the filament current is supposed to be around 150 milliamps. So if that's what we've got showing on the meter, we're pretty good there. So again, we'll go slow with this. I've got it on the variac, so we can go up with the voltage slowly and power them up that way. So anyway, that will give us our filament voltage on the correct tubes, the audio tubes. So that would be that part of the power for that. So let's go take a look at now and see what we do, how we're going to do the B+. Okay, now we're here over in the power supply section, and you can again see the rectifier, the 35Z5 is crossed out. It will not be there. So we don't have to worry about where we connect our 140 volt DC. And what we're going to do is connect it right at the output of the rectifier tube there in front of R16 or 18, I can't tell. Yeah, 16, 18 I think is what it is. Anyway, it's a 22 ohm resistor. We're going to put the one lead, the positive lead, there on that one, and the negative lead from the cap checker will go to ground, basically. And that should give us the correct amount of B+ to operate those tubes on the audio section. So if that's the case, we should hear some sound coming out when we get this done. So there's our pretty much our entire operation here that we're trying to accomplish. Again, with the tubes removed, we should have no extra excess current being drawn. In other words, with no tubes, there's not going to be any current drawn, and because there's no reason for it to be drawn. So there will be a little bit of a loss between resistors and ground connections, things like that, but I don't believe it's going to be anything significant to drag this down. Now, I think it doesn't say the normal voltage here at this point, but from past experience working with All American 5 radios, the 140 should just about be right on this this point. And if it's actually too low, if we monitor it and it comes out too low, we can move the connection point over one resistor there and bypass that 22, and that will give us a little bit more current, and we could just do that, or we could even bypass the other one, the 220, and give it right at between the 220 and the 1000 ohm resistors there, 17 and 16. And that would give us even more current if we need it. But I don't think we're going to. I think it'll be fine just where it's at. And so, you know, provided that the cap checker puts out enough voltage or enough current, I think this will work out just fine. So, okay, we're back, and the video is getting a little long now. I think we're going to go ahead and do this in 2 parts. So this will be part 1. And join me later on when I get it done for the actual bench portion of this. And that will be the exciting part, so stay tuned.